Welcome to this explainer. Today, we're diving into a massive structural force and the cutting-edge science that's driving a multi-billion-dollar revolution in agriculture. Look, if you're an agricultural professional, or honestly just someone who eats food and cares about the future of our planet, you're definitely going to want to stick around for this. We're going to break down some incredibly complex biological concepts into a clear, visual narrative to show you exactly how farming is fundamentally changing, literally from the soil up.
Let's kick things off with a number that should make anyone in the ag sector stop and listen. $18.75 billion. That's where the agricultural microbiome market is projected to skyrocket by the year 2030. But what's even more mind-blowing is the growth rate. It's expanding at a massive 14.7% every single year. We aren't talking about some slow, incremental shift here. This is an absolute explosion. And understanding exactly why this market is growing at nearly 15% annually is absolutely crucial for your future strategy. So, to unpack this explosive growth, here's our roadmap. We'll quickly cover the mega market itself, then the science of the holobiont, the four core drivers fueling this expansion, the real-world impact of BNI technology, and finally, we'll map out some future strategies.
All right, Section 1, the $18.75 billion mega market. Let's look at the sheer scale of the economic opportunity in front of us. Now, multiple research institutions totally agree on this double-digit trajectory. We're looking at a market expanding from an estimated $9.45 billion in 2025, essentially doubling by 2030, and then projecting out to a staggering $38.1 billion by 2035. To put that into perspective, it's basically quadrupling in a decade. The wider agricultural biological sector is booming right alongside it too. Oh, and keep an eye on the Asia-Pacific region. It's currently acting as the fastest-growing hub globally, thanks to some massive, surging demand.
But you know, this huge influx of cash isn't just some random coincidence, right? It's a direct, urgent response to the two massive limits of modern farming we're hitting right now. First, we're facing the devastating reality of severe climate stress causing huge yield reductions. And second, our heavy, costly dependence on nitrogen fertilizers is causing terrible nitrate runoff, polluting our water and generating greenhouse gases. The old way of doing things? It's breaking down, both economically and environmentally.
Moving on to Section 2, the holobiont paradigm shift. To fix these systemic problems, the whole industry is embracing a brand new biological era.
Okay, the absolute linchpin of this entire shift is a concept called the holobiont. Now, historically, we always looked at a plant in isolation, right? Just the plant. The holobiont concept totally flips that. It means a plant and its surrounding microbiome are no longer viewed separately. They're seen as one complete, integrated biological system. It's the realization that the plant is just the host in a bustling, microscopic metropolis. So, we're leaving behind the era where we just focused on a solitary plant and tweaked its individual genes. Instead, we're stepping into a reality where we actively harness the power of up to 10 billion microbes per single gram of soil. 10 billion! The plant isn't alone out there. It's surrounded by this invisible network of evolutionary partners constantly exchanging nutrients, water, and defense signals. We're managing vast ecosystems now, not just crops.
So how does this actually play out on the farm? Well, conventional agriculture focuses mostly on plant genetics and relies super heavily on expensive chemical fertilizers, leaving it really vulnerable to climate change. Holobiont agriculture changes the whole equation. By focusing on the entire symbiotic system, we can replace that harsh chemical dependency with highly efficient microbial functions. It builds resilient natural networks that actually withstand environmental stress. Think of it like a fundamental upgrade to agriculture's operating system.
Section 3, 4 drivers of market growth. What is actually fueling this market to grow at that insane 14.7% annual rate? Let's break it down. For the ag professionals tuning in, this is the crux of the whole thing. We've identified 4 distinct structural drivers pushing this 14.7% growth. We're talking top-down regulatory pressure, major shifts in corporate sourcing, a massive technological convergence, and finally, a core scientific challenge that companies are racing to solve. Let's take a closer look at these forces. First, the economic pressure is immense, and it's happening right now. Retail giants like Walmart are already forcing over 2,000 of their suppliers to hit zero pesticide residue. Zero. Meanwhile, entire continents are literally changing the law. The EU's farm-to-fork strategy mandates a 50% reduction in chemical pesticide use by 2030. They are forcing the entire supply chain to transition away from traditional chemicals toward biological, holobiont-based alternatives.
And on the tech side, the convergence of AI, synthetic biology, and genomics is sparking innovation like we've never seen. Get this, patent applications for modified microbial strains surged by 340% in just 2 years. 340%? And the money is following the science. We saw $1.8 billion in venture capital pour into ag biotech startups in 2024 alone. The smart money absolutely knows this is the future.
Let's move to Section 4, the impact of B&I technology. I want to show you a concrete example of this science actually working in the field.
A prime example of this revolution is a core technology called B&I, which stands for biological nitrification inhibition. Basically, it's a natural phenomenon where the plant itself actively secretes specific substances right out of its roots. It forms this incredible natural protective shield, interacting directly with the soil microbiome to stop added nitrogen from turning into a form that just washes away into the environment.
Here's the exact mechanism, and it's brilliant. In normal soil, nitrifying bacteria quickly convert your expensive fertilizer into nitrate, and a lot of that just washes away in the rain, polluting rivers. But in B&I soil, the plant's root secretions actually block those specific bacteria. This keeps the nitrogen in an ammonia state much longer in the soil. For the farmer, this means radically improved absorption efficiency, high yields, and a massive reduction in the amount of fertilizer you actually have to buy and spray. It's a total win-win.
But you might be wondering, how do we actually find and optimize these invisible interactions in the dirt? Researchers are using something called the panoomics approach. They aren't just looking at DNA anymore. They are layering genomics, transcriptomics, proteomics, and metabolomics into one gigantic interconnected dataset. They fuse all this into a comprehensive mathematical model to completely map the unseen symbiosis happening underground. It's like putting together the most complex puzzle on Earth.
And this data feeds directly into real product development. By pairing that massive panomics data with GNAS, genome-wide association studies, scientists can basically scan through the DNA barcodes of plants to accurately predict key genetic candidates. They can link a specific DNA sequence directly to traits like B&I activity. This paves the way for the ultra-high-speed development of next-generation crops, letting us tap into forgotten genetic resources to build the perfect Holobiont.
Finally, Section 5, Scenarios and Future Strategies. Let's look at how to navigate this market over the next decade.
All right, here are 3 projected scenarios for the market. And the crucial thing to note across all of them is that they hinge on solving the 4th driver we mentioned earlier, the reproducibility challenge. See, field trials show that the exact same microbe can have a 30 to 70% variance in effectiveness just based on different soil types. If AI and synthetic biology solve this variability, we rocket into the optimistic scenario of over 15% growth, where biologicals replace chemicals globally. If we don't solve it, we're stuck in a cautious scenario with single-digit growth limited to niche organic farms.
So how do top companies navigate that risk? For cutting-edge players like T3, their strategy is super clever. They're utilizing archaea, which are ancient microbes naturally found in extreme, harsh environments, to provide a highly stable solution to that exact field variability problem. Plus, they're looking at the holobiont not just as plant food, but by connecting it to the human gut microbiome. This medical food agriculture healthcare angle offers an incredible untapped market hedge that traditional chemical competitors haven't even factored into their business models yet.
And remember, none of this is happening in some isolated corporate silo. There's already an active international research network, the Global B&I Consortium, driving the practical, real-world application of these technologies. They are collaborating worldwide to localize these sustainable, holobiont-based techniques so they actually work consistently, whether you're farming in the dry heat of Africa or the temperate soils of Europe.
Ultimately, what this explainer has shown us is that deeply understanding and utilizing the natural, complex diversity of the plant holobiont is simply the most reliable path forward. It's the absolute key to creating resilient crops and ensuring global food security in the face of rapidly accelerating climate change, all while actively repairing the earth instead of degrading it. Look, the biological revolution in agriculture is no longer just a cool concept for tomorrow. It is a multi-billion-dollar reality actively reshaping the fields today. So the big question you've got to ask yourself as we wrap up today is this. As the lines between medicine, food, and agriculture completely blur together, how will you adapt to this interconnected future? Thanks so much for joining me on this deep dive. Start preparing now because the paradigm has already shifted.